I want to take you back to the year 1980.
3 years earlier, several personal computers had made their way to the market, such as the Apple II, TRS-80, and Commodore PET. And while these computers were considered very affordable for the time, they were still out of reach for a lot of people. By 1979, some more affordable options began to show up, such as the Texas Instruments TI-99-4 and the Atari 400, both of these costing around $550 at the time. Now, while these newer computers were cheaper, they were also better because they had added considerably more advanced graphics and sound capabilities, and these computers were capable of more than just being computers. They could wow their customers with fancy video games. And while these computers were more affordable than ever before, another computer was about to enter the market which would really bring the cost down. If you thought I was about to say the Commodore VIC-20, that was a good guess. But that wouldn't show up on the market until 1981.
No, I'm talking about the Sinclair ZX80. Now, this was designed by a company in the UK called Science of Cambridge, but they later changed their name to Sinclair Research. There was literally one design goal for this computer, that it would be cheap. And that is this computer's distinguishing feature, and every design decision made about this computer would be about cheapness.
The ZX80 would lower the bar even more on affordability, starting out at £79 for a do-it-yourself kit, or around £100 for a pre-assembled kit. That would be similar to $140 at the time. Now, as you can see, that's a good bit cheaper than even the Atari or the TI. And to put this money into perspective, in today's money, that meant the ZX80 cost around $455, which means you can buy a Nintendo Switch or PlayStation 4 for less money today, but, what did you get for your money?
Okay, so what we have here is the Sinclair ZX80. Now, while this machine was designed and sold primarily in the United Kingdom, they would output PAL video and therefore not be compatible with North American televisions. However, this particular unit here, you'll notice that it says model ZX80 USA. So this is a fairly rare machine. There weren't that many of these that were sold in the USA, but this one actually does output NTSC video. Okay, so let's talk about some of the cost-cutting measures just in the external design of this thing. I mean, for one thing, it's you can see that it's just a shell of two pieces of plastic, one piece on top and one on bottom. And you can also see that it's really, really small. And, size is, the smaller it is, the cheaper it's going to be to manufacture the plastic. Now, this looks like it would be a ventilation system here, but this is actually, it's just painted on. There's no actual holes to allow any ventilation to go out. On the back, these are the only ports on the entire computer. I mean, there's no ports anywhere else. All you have back here is a video output port. Now, this is an RF modulated port, so it's not composite video. You actually have to hook this into the antenna jack of your TV. And then here you'll notice you have three identical looking jacks, and one of them is 9 volts DC in. This is the power port. And then these two are for a tape recorder. And one of the really annoying things about this is they do use the exact same connector in all of these. And so it is possible, for you to stick the power connector in the wrong port and theoretically fry something. And then over here is basically a connection for the entire system bus. And there are a variety of peripherals that can connect to this, which I will talk about later.
Okay, let's take this thing apart and see what makes it tick. In order to take it apart, there are these 7 little fasteners, and the way these work is you just need something to push these little posts out, like this, and then you can remove the whole thing. I'm guessing these were cheaper than metal screws. Now we can lift the top off, and as you can see, there isn't a whole lot going on here. In fact, the simplicity of this machine is mind-boggling.
Another thing I'd like to point out about this is if you look right here towards the edge on both sides, you'll see it looks like a metal RF shield. And also, if you look at the inside of the top cover, you'll see what looks like an RF shield, but it's actually not. It's actually painted on conductive material used as an RF shield. Very interesting.
The keyboard is almost part of the main PCB, and the traces on the PCB definitely look like they were hand-drawn and not computer designed. So let me give you a little overview of how this thing works. The most important chip here is this big one, and it's a Z80 microprocessor clocked at 3.25 MHz, and that speed is most likely picked for a specific reason, which I'll discuss in a minute. These two chips here are static RAM chips, giving the machine a whopping 1K of RAM, and up here is a single 4K ROM chip that holds everything, including the character set, basic, and all the input-output routines, etc. All of the rest of these chips are just standard TTL logic chips. So if you're thinking, well, gee, where's the audio and video chips? Well, I can answer that audio easily enough. There's not any. This computer has no audio whatsoever, not even a beep. It's totally silent. Okay, well, what about video? Well, technically it doesn't have one of those either. The video itself actually comes out of this chip here, which is just a standard off-the-shelf shift register. So it can only produce 8 pixels before being fed more data. And where does that data come from? If you guessed the CPU, you guessed correctly. The CPU speed of 3.25 MHz was probably picked to help the CPU be in sync with a composite video display. In fact, this system is so cheap they didn't even use a quartz crystal, instead using a ceramic resonator, which you can see here. Well, let's plug this thing in. I'll need an actual television because I'll have to use the antenna jack and tune the TV to channel 2. There is no power switch on the computer. Remember, I said it was designed to be as cheap as possible, so as soon as you plug it in, it comes on, or rather it's supposed to. I think the power port on mine might be a bit oxidized. There it goes. Okay, so that annoying noise is coming from the speaker in the TV, but since this computer has no actual audio, I might as well just turn the volume down to 0. Okay, I'm going to go ahead and try typing in a small basic program. You'll notice there are actually different basic commands printed above the keys, so you don't actually type out the basic command. So you'll see the word print is right above the letter O. So I'm just going to push O, and then you'll see the entire command just appears on the screen. Now I'll try to keep typing out my program. I have to say, this is the worst keyboard in the entire history of computers. Not only because it's a membrane keyboard, but because the layout of all the keys is especially irritating as well. By the way, if you keep thinking the screen is shutting off when I type a character, you aren't imagining it. The CPU in this computer can either run software or update the screen, but it can't do both at the same time. Hence why most computers had a dedicated video chip. Once you finish a line, it'll send it to the top of the screen, and you're always typing on the bottom of the screen. And there's a surprising reason for this. So here's my program. Now, you might think the screen is actually scrolling here, but the program has actually stopped with an error code. Unlike other computers, the ZX80 only displays a numerical error code. The first number of the code is the error type, and then the second number is the line number that it occurred on. The reason for this is the ROM wasn't large enough to contain actual error messages that could be printed on the screen. Anyway, so what does error code 5 mean? Well, let's take a look at the manual. Believe it or not, error code 5 means no more room on screen. And that's why my program ended with an error code. You see, the ZX80 doesn't scroll the screen like other computers. If it did, then what would happen is the program would continue running, and thus the screen would stay black, and you'd never be able to see what was happening because of the way the CPU can't display the screen when a program is running.
But if you think that's irritating, you haven't seen the worst of it yet.
The text screen is 32 characters wide by 24 characters tall. That's not terribly bad by the standards of 1980. It's better than the VIC-20 and about the same as Radio Shack's color computer. But here's the real problem. That means a full screen of text will use 768 bytes of RAM. I want you to think about that for a moment, because if you remember, when we were talking about the motherboard, it only has 1K of RAM total. So literally, if you look at the system RAM, you'll find that 3/4 of the RAM is used by the screen RAM, leaving only 256 bytes of RAM to write code with. It's probably even worse than this, as the operating system probably uses at least a little RAM for itself. However, the operating system is very clever. Once you go over 256 bytes, which isn't hard to do, a single screen full of basic commands will usually do it, your program will start to intrude into screen memory. It's actually designed to do this, so what happens is the screen will start to shrink from the bottom up. So the more you type, the smaller it will get. And this can be particularly irritating when trying to scroll through and edit a program, because it can get to the point where you only have a few visible lines to work with. Eventually, you'll end up with just one line, and it won't let you go any further. The only way to store programs on your ZX80 was by connecting a cassette recorder, which of course was fairly standard on home computers at the time, but there were never any other storage mediums for it, and even though it had a cartridge slot of sorts in the back, this was never used for game cartridges. Oh, and one interesting observation about this port, by the way, I noticed the port is a card edge. This is exactly opposite of how most home computers were, where the cartridge itself would have the card edge, and then the computer or the video game console would have the female connector. Now, this is another one of those weird cost-saving measures. I mean, you see, the female card edge connector costs more money. So on a system like an Atari 2600, for example, you would want to put the expensive part inside the console, and that way the 100 or so cartridges a user would buy would be cheaper because they could use the standard PCB-style card edge. But with the ZX80, they wanted to save every penny on the cost of the machine. So had there been any game cartridges made for it, they would have all needed to incorporate the more expensive connector in every cartridge. There were hardly any graphical games, but there were a few, such as this Space Invaders clone. Granted, I use the term graphical very loosely here. The game is remarkable, not so much for how it looks, but for what they were able to accomplish given what they had to work with. The most amazing part is that it's able to multiplex the gameplay with the video display so that the game works simultaneously with video. Okay, let's face it, the ZX80 is a terrible computer. It was designed with one goal in mind, and that was to be cheap. And while it did achieve that goal, it came at the cost of essentially reducing the computer down to a glorified calculator that could just happen to connect to your TV rather than being an actual real computer. Now, don't get me wrong, the computer was a commercial success, and I suppose a lot of people probably got their start in computers using this product. And so I can't fault it for that. However, there's probably also a lot of people who got their start and a very quick finish in the computer industry because they started with one of these, so that can go both ways. However, the product did get better. The very next year in 1981, a new model was introduced called the ZX81. Now, this computer will be the one most people will remember as it was considerably more popular. It's actually even smaller than the ZX80, which was already pretty small to begin with. It has essentially the same membrane keyboard as the ZX80, although some things are rearranged a bit. On the rear, it has the same expansion port as its predecessor, and on the side it has the same RF-style TV output, along with power and tape connectors, just like its predecessor. However, this one does have some significant differences. I'll start by taking it apart, and already you can see that it uses real metal screws. Upon seeing the motherboard, it's noticeably smaller as well, and when looking at the other side, you may notice it only has 5 chips. Now let's do a side-by-side comparison of the two boards. They both use the same Z80 processor, they both have a ROM chip, although the new system has an 8K ROM instead of 4K. They both have a measly 1K of RAM. But what is this chip called a ULA? Well, believe it or not, they have essentially consolidated all of these other logic chips into a single custom chip to further reduce cost. So while the ZX80 was made from more or less off-the-shelf parts, the ZX81 finally has a custom chip. These computers are almost the same computer, but let me summarize the main differences between them. Obviously, the chip count is smaller on the 81, but also the price. And that's right, the ZX81 sold for £49 in the UK and under $100 in the USA. The 81 has a larger ROM. The original BASIC could only handle integer math, whereas the new BASIC does floating point and some primitive graphics, which I'll talk about shortly. Another big improvement was something called slow mode. Now, you might think slow mode sounds like a disadvantage over something that's fast, right? I mean, at least in the world of computers. Well, with slow mode, the ZX81 can finally do two things at once. It can generate video while also executing program code. Now, how does it do this? Well, if you look at the screen in a CRT, as you know, the screen is drawn 1 pixel at a time from the top left to the bottom right. Well, during the time it's drawing the border at the top and bottom of the screen, the CPU is not really needed much, so the CPU can execute other code during this period. So, in fast mode, the CPU either devotes all of its time to program execution or all of its time to drawing the screen. In slow mode, the CPU will multitask, and about 70% of its time is spent drawing the screen, and what remains is left for executing other things. And while it does slow things down, during regular usage, this is actually preferable because at least the screen doesn't flicker off every time you press something on the keyboard. Sinclair also offered previous owners of the ZX80 an upgrade path. Since the computers were more or less identical in function, ZX80 owners could swap out their ROM chip with a newer one, plus a small hardware modification to allow slow mode, and they would even receive a new keypad that had all of the new features printed on it. And this upgrade cost about 20% of what it would have cost to just buy the new ZX81, so that was a fair strategy. The ZX81 was also destined to make more of an impact in the USA.
People than ever before. Introducing the Timex Sinclair 1000, the first of a new generation of computers designed to be easier to use and to own. For $99.95, power to learn at the...
Timex, yes, that's the watch company we all know, collaborated with Sinclair Research to market the computer in the USA as the Timex Sinclair 1000. On the back of the box, it says it utilizes 4 powerful microchips, including a unique master chip that replaces as many as 18 chips on other personal computers. And that's interesting because the ZX81 had 5 chips, and it also states it comes with 2K of RAM. Still not much, but it's twice as much as the ZX81. Timex also sold a 16K RAM module and a tiny little Timex personal printer. So let's open it up and see what's inside. Even the foam has the Timex logo. It's pretty obvious my box is missing a few things, but it does at least have the user manual. And this manual is not bad. It's not as good as the VIC-20 manual, but certainly decent. Let's compare it with the ZX81. Other than the logo, they look identical, but there are some minor differences. For one thing, on the keyboard, they changed some of the British terms. For example, we have rub out here, and the American version says delete. On the side, you may notice the RF video output is in a slightly different place, but they do have the same expansion port. Okay, let's take a look at this RAM module. While 2K of RAM is certainly an improvement, this module will give us 16K of RAM, and that's enough RAM to actually be useful, especially considering this computer has no graphics mode, so there's no need to store graphics anywhere or sound or any sort of DOS for controlling disk drives, so all of the 16K is available for use. Of course, it does have the female edge connector, like I mentioned earlier, and so it attaches like this. And this one's pretty tight, which is good. I've had them kind of loose before, which is bad because sometimes just touching the computer would make it lock up due to the port connection. Timex also marketed a few cassette-based applications, which were typically sold wherever the computer was sold. I have no idea what that is, but one thing I wanted to mention is that some games like this one say they work on 2K of RAM, and same with Money Analyzer, but notice this one says it needs 16K, and another. And this is somewhat unusual for the era because typically RAM expansion units in other computers were rarely supported by software, so this tends to suggest the RAM upgrade was pretty popular for this computer. Even though there was really no commercial market for games on this system, there were quite a few homebrew games developed, and most games were found in computer magazines. Some were type-in listings printed in the magazines, where some were simply mail order ads where you would send off and get a cassette mailed to you. None of these games are likely to impress a serious gamer. However, I do find some of them impressive just considering the system they were made for. Officially speaking, the Sinclair units have no graphics modes at all. I mean, they do contain a character set with several predefined graphics characters, similar to the Commodore and the TRS-80 models. By using these, you can create pseudo-graphics. And even if it did have a graphics mode, there isn't enough RAM to store any graphics on the base models. However, since the graphics are software generated, with a 16K RAM expansion and some minor modifications, you can actually do custom high-res graphics, like some of these games. There weren't very many that took advantage of this sort of thing, but the ones that do are fairly impressive. There are also some demos that make use of it. There were also a variety of methods to get sound out of the computer, such as using the cassette port to generate some simple beeps, and even going so far as to integrate a sound generator chips from other platforms. However, very little software takes advantage of that either. Another popular upgrade modification was in the form of aftermarket cases and keyboards, which, when combined with a RAM upgrade, could make these computers almost functional and tolerable computers to work on. The Timex unit was at one point selling for as little as $49. One funny situation this created is that Commodore had been running an advertising campaign claiming to give people a $100 credit for the trade-in of any computer or game system. So many people realized they could buy the Sinclair unit for $50 and then trade it in for a $100 credit on a Commodore. Of course, a couple of years later, Timex came out with the Sinclair 1500. Now, this version comes standard with 16K of RAM and a much better keyboard. Here we go. It has all the same ports on the back, but one thing I noticed right away is that it's substantially heavier, which is a good thing compared to the previous units. Now, the keys are chiclet keys, which are typically hated in the computer industry. However, compared to the membrane keyboard, these are like heaven to type on. I mean, I guess everything is relative. The user manual for the 1500 is also pretty nice. Now, let's have a look inside. It's a little bit more advanced, and obviously it has 8 RAM chips. The ULA is now in a square package instead of a dip. But overall, the architecture is almost identical to previous versions. The Sinclair 1500 was ultimately a market failure, despite the fact that it was sold for around the same price as its predecessor, only it's actually a usable, functional computer that you could actually do stuff with. The problem was the competition was fierce by 1983, particularly from products such as the Commodore VIC-20, but also from Sinclair's own new product called the Sinclair Spectrum, which we'll talk about in another episode. The Sinclair ZX81 can be seen in some TV shows, such as the IT Crowd, where it's even mentioned a few times.
She is quite the oddball. Did you notice how she didn't even get excited when she saw this original ZX81?
Yeah, no.
And while not actually shown, it is mentioned on Red Dwarf.
I was in love once. A Sinclair ZX81. People said, no, Holly, she's not for you.
I think the Sinclair units were kind of important from a perspective of getting the cost of computers down, but to compare them with cars for a moment, buying a ZX81 was sort of like buying one of those motorized shopping carts you'd see in Walmart and claiming you'd bought a car, where buying a VIC-20 at the time was sort of like buying a Nissan Versa or a Chevy Spark. I mean, sure, they're cheap, but at least they're a real car. And so we're not quite done talking about the Sinclair systems yet because we have to cover the Sinclair Spectrum, which was a far more iconic computer, I think, particularly in the UK, and we'll get to that in a later episode. But as far as these systems go, they are historically important for being the butt of computer jokes, for one thing, but beyond that, they do deserve special recognition for bringing the cost of computing down and just for their sheer simplicity. I mean, some of the design decisions they made in these computers, and while, yes, they ultimately made the computers less usable, some of them were brilliant as far as how to get the cost down and actually have a computer that can hook up to a television. So they do deserve recognition for that. And so that about wraps it up for this episode. So as always, thanks for watching and stick around for the next one.